In last lecture, we have read about the extraction of metals, how highly reactive metals are extracted from their ores. In this, we have studied the example of aluminium, how aluminium is extracted from the bauxite. Today, we will see our next point, that is the extraction of moderately reactive metals, how moderately reactive metals are extracted from their ores. Moderately reactive metals, they are at the in the middle of the reactivity series, such as the iron, zinc, lead, copper. These are the moderately reactive, and usually they occur in the form of their sulfide salts or carbonates. It is easier to obtain metals from their oxides rather than sulfides or carbonates. Metals are always found in the nature in the form of sulfides and carbonates, but it is hard to obtain these metals from these sulfide or carbonate forms. So it is easy to obtain metals from their oxide forms. So first we have to convert sulfides or carbonates form into oxide forms, and then we have to extract the metals from these oxide forms. Therefore, the sulfides are strongly heated in the air to transform into the oxides. This process is known as the roasting. In roasting process, sulfide forms of the metals are heated in the air and it is transformed into oxides. This is the roasting. And carbonates ores are strongly heated in a limited supply of air to transform into its oxides. This process is known as the calcination. Means roasting and calcination, these two processes are used to form the oxides of the metals. In roasting, we transform sulfides form of sulfide ores into the oxides, and in calcination we convert the carbonate forms into the oxide forms. The following reaction occur during the roasting and calcination. We can see the reaction. Zinc sulfide is reacted with oxygen and it forms zinc oxide and sulfur dioxide gas. This is the roasting method. That means the sulfide form is reacted or heated in supply of air and it forms zinc oxide. And in calcination process, zinc carbonate form of zinc is heated into the limited supply of air and it forms zinc oxide and carbon dioxide gas is liberated. These two methods are used for the extraction of moderately reactive metals. The zinc oxide so obtained is reduced by zinc by using suitable reductant such as the carbon. Means from the zinc oxide we obtain zinc by using the reductant such as the carbon. Carbon is a non-metal. We use non-metals like carbons to reduce the zinc oxide and it forms zinc metal. The reaction is shown here. Zinc oxide plus carbon, it forms zinc plus carbon monoxide. Apart from carbon, reactive metals such as the sodium, calcium, aluminium are also used as a reducing agent for the reduction of metal oxide to obtain the metal. That means instead of the carbon, we can also use the sodium, calcium or aluminium. These are the most reactive metals than the zinc, and they can replace the zinc from its oxide form, and we can obtain the metal. This is because these metals displace a moderately reactive metal from its compounds. And for example, when manganese dioxide is ignited with aluminium powder, the following reaction takes place. Manganese dioxide, that is the MnO2, it reacted with aluminium. Reaction is shown here. Thrice MnO2 plus 4Al, it forms manganese metal and aluminium oxide is also formed, and tremendous amount of heat is liberated out. Identify the substances undergoes oxidation and reduction in this reaction. Oxidation means combining with oxygen or removal of hydrogen, and reduction means combining with hydrogen or removal of oxygen. In this reaction, manganese oxide is reduced, it forms manganese, and aluminium reacts with this oxygen and forms aluminum oxide. Here aluminium is oxidized. The heat evolved in the above reaction is so large that the metal is formed in the form of molten state. Due to large amount of heat, the metal formed is in molten state. Another similar example is the thermit reaction. Second example of this type of metal extraction is the thermit reaction. In thermit reaction, iron oxide reacts with aluminium to form iron and aluminium oxide. Here ferrous oxide is reduced and aluminium is oxidized, and it forms ferrous metal or iron metal and aluminium oxide, and a lot of amount of heat is liberated in this reaction also, and due to this ferrous is in molten state. The diagram number 8.30, that is thermit welding, this is related from the syllabus. So we see then our next point, that is the extraction of less reactive metals. How less reactive metals are extracted. Less reactive metals are at the bottom of the reactivity series of metals, and they are less reactive. That is why they are found in the pure form or free state in the nature. Examples of less reactive metal is the gold, silver and platinum. The reserves of copper in the fresh state are very low. Presently, copper is found mainly in the form of copper sulfide. Copper is obtained from copper sulfide or just by the heating in air. Copper sulfide is heated in air and it forms copper oxide, and sulfur dioxide is liberated, and from copper oxide by using copper sulfide we can obtain the copper metal, and sulfur dioxide gas is also liberated here. That means by these methods we can extract the highly reactive metals, moderately reactive metals and less reactive metals. We use different methods for this type of metals. The next point, that is collecting information and refining of metals, it is deleted from the syllabus, so we will see our next point, that is the corrosion of metals. What is meant by the corrosion, how it is done? Old iron bars of buildings, copper vessels not cleaned for a long time, silver ornaments or idols exposed to the air for a long time, old abandoned vehicles fit to be thrown away. You have seen this type of instruments around yourself. This is the corrosion of the metals. That means the old iron bars, they are they shows corrosion. Copper vessels are also shows corrosion, but the form of corrosion is different in different type of metals. You can see that the silver articles are turn blackish after its use. After a long time it shows black color, while copper vessels shows the greenish color. But the pure gold and platinum always glitter. They do not show any type of color change. Rusting of iron articles causes large financial loss. Due to the rusting, iron articles loses its quality, or it becomes poor, and we have a large financial loss. This corrosion of iron, that is rusting, is a big problem. So it is a big problem in front of us. Iron reacts with moist air. How corrosion is done? See, iron metals, how it is corroded. Iron reacts with moist air and a deposit of reddish substance is formed on it. When iron particles are opened into the air, and if it is moist air, then it reacts with this iron and it forms reddish substance on its surface. This substance is called as the rust, and the formula of rust is the Fe2O3 H2O, ferrous oxide with the vapor water. This is known as the rust, and it is known as the corrosion of iron. In copper vessels, how corrosion is done? Carbon dioxide in moist air reacts with the surface of the copper vessel. In copper vessels, the carbon dioxide from the moist air, it reacts with the copper vessels, and copper loses its luster due to the formation of greenish layer of copper carbonate. Due to the action of the carbon dioxide, there is formation of copper carbonate, and greenish layer of this copper carbonate is deposited on the surface of these copper vessels. The formula of copper carbonate is CuCO3 on the surface, and this is called as the potentiation of copper. You can see this type of vessels in your house. The vehicles, the utensils used in your god worshipping, these are copper, and they become greenish when we do not wash them for a long time. They shows greenish layer on its surface. Next is the corrosion of silver. On exposure to air, silver articles turn blackish after some time. And this is because of the layer of silver sulfide, that is Ag2S, formed on the reaction of silver with hydrogen sulfide in air. Silver reacts with the hydrogen sulfide gas which is present in air, and it shows blackish layer on its surface. This is also a corrosion of the silver. By oxidation of aluminium, a thin layer of aluminum oxide formed on it. After oxidation of aluminium, a thin layer of aluminum oxide is also formed on the surface of the aluminium utensils, and is known as the corrosion of the aluminum. That means the every metal reacts with various gases present in the air and shows corrosion. Due to corrosion, the quality of these substances get poor, and there is a large financial loss. So we must have to prevent the corrosion. How corrosion is prevented? We have to see the preventive measures, how corrosion is prevented, but we will see this point in the next lecture. Today we have see how moderately reactive metals are extracted from its ores, and how less reactive metals are extracted. and then we have seen the corrosion of metals, how corrosion is done, which metals show corrosion and which gases in the air if it is these vessels. In next lecture we will see the prevention of corrosion, preventive measure of corrosion. Today I have taught you these points. You have to read these points and write the short note on corrosion of metals in your notebook. Here we will stop today. Thank you.